In this class I am going to explain you about zero order reaction from chemical kinetics. What is order of reaction? Order of reaction is defined as the sum of powers of concentration terms of reactants in a rate expression. That is called order of reaction. Order may be 0, fractional, positive, negative and integer. Order of the reaction can be determined experimentally. See, order may be 0, that reaction is said to be zero order reaction. We have zero order, first order, second order and third order of course. Among all, I am taking here zero order reaction. In zero order reaction, order of reaction is 0. That means rate of reaction does not depend on the concentration of reactants. See, for example, in a chemical reaction, A is the reactant which converts into products. Say rate of reaction is directly proportional to the concentration of reactants. But in zero order reaction, rate of reaction does not depend on the concentration of reactants. That's why it is called as zero order reaction. N value is 0 here. R is equals to say K into A naught. So because it is independent on the concentration of reactants, the graph when we plot like this, rate versus concentration of reactants, it is independent. We get the constant line like this. Say for example, it is equation number 1. Second one, we can write the rate expression for this. Rate with respect to reactants, how can we write? Minus stands for decrease in the concentration of reactants. A by dt. Say it is equation number 2. From 1 and 2, so K is equals to minus dA of dt. We can write like minus dA of dt, dA by dt is equals to K, where K is the rate constant for zero order reaction. In some books they may write K0 also. So dt when comes there towards K side, minus dA is equals to K into dt. When we multiply the equation by minus, we get minus K into dt. When we integrate this equation, integration of dA is equals to minus K is the constant, it does not integrate dt. So you know integration of dx equals to what? X. Integration of dx equals to x. Like that, A is equals to minus kt and we get an integration constant here. Say equation number 3. Yes, right. At time 0, reaction has not started. At time 0, the initial concentration of reactant becomes A0. A0. At T0, A becomes A0 or A0. See, at time 0, the concentration of reactants is A0 minus K, T value is 0, I is there. Here 0 we get, I is equals to this value. A0 is equals to integration constant, say 4. So 4 substitute in 3, 4 in 3. Now we get concentration of A is equals to minus KT plus, instead of I write A0. Right? See, we can rearrange those terms and we get this equation. A is equals to A0 minus KT, right? See, when KT, we write KT like this, KT is equals to, and see one graphical form we can write here. When you rearrange those terms like this, A is equals to minus KT plus A0 plus A0. Now Y is equals to mx plus c, mx plus c. Concentration of A X value is what? T. Slope is negative. So how much is the slope? Slope is minus k here. Okay. Minus k here. Here intercept value is how much? A naught. Intercept value is A naught. This is another graphical form for zero order reaction. Okay, this is one fact. And next one, see, from here I am going to write the K expression, rate constant of zero order reaction. See, when Kt comes here, A goes there, K into T is equals to A naught minus A, concentration of A. K is equals to A naught minus A divided by T. So this is the rate constant for zero order reaction. Okay. Now, what are the units for zero order reaction? Units. See, we have a trick for this, moles per liter per second. Here 1 minus n, n minus 1, n value is 0. Now, moles per liter per second. So this is the unit. This is the unit for zero order reaction. See, it is concentration, it is time. Concentration, moles per liter per second. So this is the unit. Now we can calculate the half-life of zero order reaction. Half-life means what? The time taken to half of the initial concentration of the reactant is called half-life. Half-life is denoted by T half. Half time, like that, T 50%. Okay. Now we calculate the T half. How can we calculate the T half for zero order reaction? See, simply half-life. Half-life means here T half. The time required to half of the concentration of initial concentration of reactant is called half-life. See here, when T becomes T half, initial concentration becomes A naught by 2. A is equals to A naught by 2. So we know the rate expression for a zero order reaction, A naught minus A divided by T, right? So A is equals to what happens at T half? A naught by 2. I am substituting A naught here. K is equals to A naught minus A naught by 2, okay, by T. A minus A naught by 2, it will become A naught by 2. So A naught by 2 can be written like this, 2T. See here, T becomes what? T half. At T half only, A naught by 2 is the concentration of A. So when T half comes here, A naught, or I am writing 2K like this, 1 by 2K into A naught. See, it is Y is equals to mx form. Again we draw a graph. On y axis T half is there, on x axis initial concentration of reactant. So what is the slope here? Slope is 1 by 2K. 1 by 2K is the slope. It is the half-life of zero order reaction. See, if they want to get 100%, if we want to get 100% of reaction from T half, what is the direct formula? 2T half for zero order reaction. If we want to get T half 75%, 3 by 2 T half is the formula by which we can get 75% of reaction from T half. Next, examples of zero order reaction. The photochemical reaction like hydrogen and chlorine gases combined together in presence of light to form 2 moles of HCl. It is photochemical reaction. It belongs to zero order reaction, means the rate of reaction does not depend on the concentration of hydrogen and chlorine. Now ammonia, decomposition of ammonia in presence of molybdenum catalyst, N2 and 3 moles of hydrogen are formed, right? Next, 2 moles of hydrogen iodide in presence of gold. So of course it is solid, it is gas, solid, it decomposes like hydrogen and iodine. See here, reactant and catalysts, both are in different phases. When reactants and catalysts both are there in different phases, those reactions are said to be heterogeneous reactions. Here heterogeneous reactions and photochemical reactions of such type belongs to zero order reaction. So this class help you to understand the problems and derivative matter in to solve some theoretical questions, and you can substitute the relevant data what is there in the question. Have to substitute in those forms, you get the direct answer. So thank you very much.